This chapter will teach us on how to use different concurrent utilities to spawn threads for some asynchronous CDI events, non-blocking transactions, RESTful web services, server-sent events, and some EJB scheduled services. This first recipe of this module will showcase the different built-in Java concurrency implementations that can be helpful in processing asynchronous tasks of this Jakarta EE platform. There are complex asynchronous tasks that need to be backed with some background threads to avoid starvation of server resources. And there are these various Java APIs that can help define and set a pool of threads with an initial and maximum pool size, keep a lifetime out in a thread queue, ready to process these tasks outside the main thread. And this recipe will give us a tour on these topics. First, we discuss about the main interface of all concurrent thread handling utility, which is Executor. Its main functionality is to spawn a thread that will process the asynchronous task outside the main thread. Also included in the discussion is its popular derived class, which is Executor Service, that has the same functionality but offers more methods to manage the thread utility, such as knowing how many tasks were rejected by the executor itself, the manual shutting down of the executor, and returning the result of processing a callable task. In this servlet we implemented recently, we used an executor utility to help async context process its blocking transaction. And the type of an executor we use is a single threaded one, which uses only one thread to process the whole task. But there are still other types of executor we can create depending on the size and complexity of the tasks to be processed. We can create an executor with a fixed thread pool, which contains a pool of threads ready to process tasks one at a time. And when the pool is busy, it will put all incoming tasks in a thread queue. We can also create an executor that uses a work stealing pool, where threads are used to process complex tasks recursively using a level of parallelism. So we can assign here the number of threads that can work in parallel to avoid queuing of new tasks whenever all threads are busy. This type of an executor uses a fork join pool at the back to implement the whole model. To avoid queuing of tasks, we can create an executor that uses cached thread pool. Now, since there is no thread queue, a new thread is spawned for every new task if all current threads are busy. Now, this kind of an executor eats much resources and is not ideal for processing complex and recursive tasks. And lastly, we have an executor that has a thread pool that processes a task periodically. By the way, an executor utility can only offer us one method, which is execute, to perform a runnable task. Now, if we're looking for other additional methods to manage the utility, including process a callable task, we can resort to executor service. In this modified servlet implementation, I use an executor service instead of an executor to process the blocking transaction. Now, an executor service instance can be generated using the same static factory class executors with its static methods we use in setting up our executor utility. Thus, we can say that the concurrency model type we want for an executor can also be applied to executor service. Both executor and executor service has an execute method, but executor service offers a lot more methods. Instead of execute method, we rather use submit to allow us to manually shut down our executor. To shut down the utility, an executor service offers a shutdown method which returns void and a shutdown now method which returns a list of rejected tasks which we can capture for logging purposes. To shut down the executor safely, we need to invoke the await termination method to give the process the time to finish everything before the executor closes down. Executor service allows us to configure further our thread pool by implementing and using a thread factory. Thread factory are implemented by external libraries such as Guava or Apache Commons. In my sample here, I use Apache Commons Basic Thread Factory to rename the name of each thread and to assign maximum priority to all threads in the thread pool. But before we use the APIs, we need to include in our dependencies the following library. Let us now compile and run this search to servlet to show you some results. Let us now run our search to. We can see from the log that our executor service shut down safely without any rejected task. And also we can see that the name of the thread was renamed. Not only runnable, but executor service can process callable tasks, unlike runnable, produces some objects which can be extracted from its submit method wrapped inside a future task. Using futures blocking method get, we can eventually extract the value. Now running the product controller will give us this result. These are records retrieved from our data source using our product DAO class implementation. And our console log here is showing that a thread from a thread pool has processed the whole retrieval. In order to process a completable future or completion stage task, we must use an executor service that uses work stealing pool or a fork join pool per se. In this previously implemented servlet, I used a fork join pool executor to process a supplier operation needed to finish the whole completable future task operations. Now, to create a fork join pool executor, it is best to use the common pool static method of the fork join pool stat factory class, or a work stealing pool executor service, which will generate threads that will process in parallel mode.